Alright class, this is the Unit 2 Notes Day 2, adding, subtracting, and multiplying polynomials. This should be something that's kind of review. It's kind of like adding like terms from Algebra 1 and with distributing and all that other fun stuff. So let's look at what we got here. So rules to follow. You always have to combine your like terms and write your final answers in descending order. That means the power. So you want like x to the fourths first, then x cubed, and so on and so forth. So since this is adding, the parentheses can just come down because the parentheses don't matter when you're adding two numbers together. And then we're going to just look for our like terms. I'm going to look for x cubed first, and there's only one piece with an x cubed, so 7x cubed. Then I'm going to look for my x squareds. There's one, there's another. 5 plus 2 is 7. Then I'm going to look for my x's. 4 minus 8 is a negative 4x. And finally, I'm going to look for the numbers. 3 minus 11 is a negative 8. Okay, and then the degree, what's the highest degree? The highest degree here is 3, which we call cubic from yesterday. Okay, so the only difference for this one is this needs to turn all the signs in here a different sign. It changes all of the signs in here. So if I rewrite this with no parentheses, and sometimes it's better to do that first, this makes that a positive 2x. And by the way, you're not multiplying these, you're just changing the signs. Plus 2x cubed minus 5x squared minus 7x plus 4. And now we do the same process we did up above. The x cubes, or anything higher, I don't see anything higher, so negative 3 plus 2 is a negative x cubed. The squareds, minus 4 minus 5 is minus 9x squared. The excuse me, the x's is minus 12x. And finally the numbers is plus 10. And then that is in descending order. The degree again is 3, which means it's a cubic. Okay, for multiplying, it's like foiling. It is foiling actually. So, but sometimes there's bigger pieces. So for the first one, and again, if you know how to do this, you can pause the video and try them before you see the answer. First outer, so we get 10x squared plus 8x minus 15x minus 12. So our final answer is 10x squared minus 7x, excuse me again, minus 12. Still have this cough. Alright, now we're going to do that again. Now the easiest way to do these is not to try to approach them all at once. Try to work with 2 at a time. So I'm going to FOIL these, and I'm going to do that in my head because they're small numbers. You get an x squared, and then the inside is a 5x, the outside is a minus 2, so 5 minus 2 is a positive 3x minus 10. And then we have the x plus 1. So now I'm going to multiply every piece from here into each one of those. So there's going to be 6 total terms. Okay? And then we have them. So the first one is x squared times x is x cubed plus x squared. Then I'm going to do the 3x to the x. So 3x times x is 3x squared. I'll put that under the x squared piece plus 3x. And finally, we have negative 10 times x is negative 10x. And again, I'm putting them together so I can just add down at the end, the like terms, minus 10. So if you add down, we only have an x cubed. This is plus 4x squared. This is a minus 7x minus 10. And there's the answer. Okay, now this is the big one. You kind of want to organize it the same way. Every piece, so there should be 9 pieces because there's 3 of these, 3 of the middle times all of those, and 3 of the end times all of those. So for the first one, we get 3 times 4 is 12x to the 4th. 3 times 2 is 6x cubed. 3 times negative 8 is negative 24x squared. Now we're going to take the middle one and multiply that to all 3 of them. And 5 times 4 is 20x cubed, so that'll go right here. 5 times 2 is 10x squared. I'll put that one right here. And then 5 times negative 8 is minus 40x. All right. Last piece. we get a negative 9 times 4 is a negative 36x squared. I'll put that one right here. Plus, nope, negative 9 times 2 is a negative 18x. And finally, we have negative 9 times negative 8 is a positive 72. And again, I organize it this way just because it's easier to add down and then have your final answer. When you add all these together, you get plus 10 but minus 60, so minus 50x squared minus 58x plus 72. So that's the final answer right there. Whoops. Okay, I'll just do this. Alright, so let's go on the back. There's a few little special products. We've talked about this in many forms. This is the pattern that this is factored from the difference of squares, right? They're also conjugates. Remember we called these conjugates in the last unit? Which means that when you're done with this, you should just have a squared minus b squared. That's the difference of squares. Okay? Now, if you multiply this one out and FOIL it by itself, if you do a plus b times itself twice, you get a squared plus 2ab. This is kind of like completing the square, plus b squared. We get it to that point by completing the square. Now this one, you do not have to memorize this, but it's the first piece cubed plus 3 times the first piece squared and the second piece to the first, plus 3 times the first piece to the first and the second piece squared, plus just the second piece cubed. That's a pattern. But if you see something like this on the test or quiz, I would recommend you just multiply it out 3 times. That's probably the best way to do it. So you don't have to memorize those things. Okay. Let's go on then. Alright, so here's my difference of squares. And again, if you don't want to memorize them, it's fine. You can actually just do what we used to do, is FOIL them. So you get 36x squared plus 30x minus 30x minus 25. So notice that we get 36x squared minus 25. Well, sure enough, isn't that the difference of two things being squared? Yes, it is. The square root of this is 6x. The square root of that is 5. So we can make that into the pattern 6x plus 5, 6x minus 5. Okay. Now, again, if you don't want to worry about the pattern, you can just say, okay, if I'm squaring this, I'm multiplying it by itself and go through it. So we get minus 5x is minus 10x plus 25. Sure enough, it's a squared plus 2 times a and b. So 5 times 2 is 10, and then the a part was x, and then plus b squared, which is 25. Alright, so for this one, I'm going to do both methods. I'm going to use the pattern, and I'm going to multiply it out. So for this one, I'm going to multiply it out. So I get 4x squared plus 6 is plus 12x plus 9 times 2x plus 3. Alright, now I'm going to multiply it out again. So I get 8x cubed plus 12x squared. And then down the next line I have a 24x squared. And then plus 12 times 3 is 36x. And then finally we have 9 times 2 is 18x. And 9 times 3 is 27. So the final answer is 8x cubed. What else? 8x cubed, 36x squared, 54x plus 27. Alright, so now if you're going to use the pattern, I'm going to say a is equal to 5x and b is equal to negative 2. Because we'll rewrite it as 5x plus a negative 2. Okay, so if I use the pattern up above, the pattern states that it's a cubed, so a is 5x cubed, plus 3 times a squared, and then times b to the first, plus 3 times 5x to the first and negative 2 to the second, plus negative 2 to the third. Okay, so we get 125x cubed. You have to square this first. That would be 5 times 5 is 25 times 3 is 75. Oh, but I can't do that yet. It's 75 times 2 is 150. So it's negative 150x squared, because it's a negative 2. This is 4 times 5 is 20 times 3 is 60. And then that becomes a minus 8. So that's using the pattern. And if you multiplied it out 3 times, you should get the same thing. So, alright, the last thing we're going to do is variable exponents. And the only thing that's different about this is, remember, exponent properties, when you have the same base, you add the exponents. So that's what we're going to do here. We're going to multiply this out, k to the 3d plus m to the d, and then we're going to FOIL it. So when we multiply this times this together, we have to add the exponents. So that becomes k to the 6d. Then I'm going to multiply the outers, which is 3d and m to the d. They are different bases, so that means we're going to just write k to the 3d m to the d. The inside is the same thing, k to the 3d m to the d. And finally, we have the last pieces, which is, again, now that they're the same base, you add the exponents. So it's m to the 2d. Alright, and then you look for any like terms. You have, this is 6d. These are the same exact thing, so you have 2 of them. So we'd write this as k to the 6d. Plus there are 2 k to the 3d's, m to the d's. And then there's just one m to the 2d squared, or 2d, because it's already squared. And that should make sense. It follows that pattern from up above when you square something. You square the first piece, you square the second piece, and then it's 2 of those 2 things multiplied together. So it matches. Alright, let's do the last 3. These go first, so that's 5, and then when you multiply these variables together, you add the exponents, j to the 6k. Outside is a minus 2, j to the 3k, s to the 4k. 4k. The inside is plus 5, j to the 3k, s to the 4k. And finally we end with minus 2, s to the 8k, because you add those exponents. And again, we have like terms here and here, so we can add the numbers together. So I could say 5j to the 6k, minus 2 plus 5 is plus 3, j to the 3k, s to the 4k, minus 2, s to the 8k. And that's the final answer. Next, I'm going to FOIL this one out by itself. But I like to write it out so I know I'm foiling. So 3a to the p, you get 9a to the 2p. Then the inside is minus 15a to the p, b to the 3p. The outside is also a minus 15a to the p, b to the 3p. And finally we get a plus 25. And then when you add the exponents together, you get 6p. So b to the 6p. Alright, so we get 9a to the 2p minus 30 a to the p, b to the 3p, and then plus 25 b to the 6p. Okay. So there's my final answer. And our last one. Multiplying, this should be a difference of squares pattern. So we probably don't even have to do the middles and the outers. So this is 25x to the 18k. And then if you do the inside, you get 15. I'll just do that. 15x to the 9k, y to the 3k, minus 15x to the 9k, y to the 3k, minus 9y to the 6k. And again, these two cancel, because they're like terms. So our final answer is 25x to the 18k minus 9y to the 6k. And that's it. So that's using foiling and all that, but with variable exponents and some of the special products.